Hi guys, my name is Divyang. Welcome to IGCSE on Fingertips, and today we are solving a predicted paper for 9701 paper 2, which is your AS level paper 2, the theory paper of 60 marks. Let's get started. So the first question says atom contains subatomic particles, electrons, protons and neutrons. Protons and electrons were discovered by observation of their behavior in electric fields. The diagram shows behavior of separate beams of electron and proton in an electric field. Okay, protons are positively charged. So the charge on the plate should be negative for them to go on the negative plate. And electrons are negatively charged, so the charge on the plate should be positive. Let's see what are the questions. Complete the diagram with relative charge of each of the electrically charged plates. So I will write positive, this is protons. So I will write negative over here and positive over here. Clear? Then we have on the diagram, draw a line to show how separate beam of neutrons from the same source behaves in the same electric field. Because neutrons are neutrally charged, they will move in a straight line upwards because they start from the same source. So I have started them from the same source, but they do not deviate because they have no charge. Electrons in atoms up to 36 krypton are distributed in sp and d orbitals. State the number of occupied orbitals in an isolated atom of 36 krypton. So let's write this down like this, that if it has an atomic number of 36, right, meaning it has 36 protons and hence 36 electrons. So 1s2, 2s2, 2p6, then 3s2 gets filled, then 3p6. So how much is this? 12 plus 6. 12 plus 6 is 18. We have to go till 36. Then we have 3d and we have 4s. Which gets filled first, right? So I use a very simple logic that I'll give s a number 0 and the principal quantum number or the shell number itself are numbers. So s is 0, p is 1, d is 2 and f is d is not f, d is 2 and f is number 3. So if I am confused now that will 3d get filled first or 4s get filled first, I'll simply write 3 plus what is the number given to d? It's 2. So the total is 5 and the number given to 4, right, and given to s is equal to 4. So this gets filled first. Now if you notice 3p, if you write the same thing for 3p, you'll have 3 plus 1 which is equal to 4. In this case there is a tie, right? Both of the totals are 4. What you will do then, if that ever happens, and it will happen, you fill the shell with the lower principal quantum number or lower shell first, right, and then you go to the subshell. So 4s2 and 3d 10, right? Let's find out what are the number of electrons. 12, 12 plus 10, 22, 22 plus 8 is 30 and we have 4p6, right? This is the complete shell. Now the question is not about configuration. The question is about number of occupied orbitals in an isolated atom of krypton. So 1, 2, 3 and 4. So 4 orbitals of s and each p subshell has 3 orbitals. So 3 orbitals each and there are 2 orbitals each and there are 3 p subshells filled. So 6 of them and here 5 of the d, right? These are your answers. What I have done, so d subshell has 1, 2, 3, 4 and 5 orbitals, right? P subshell has 3 orbitals. S subshell has just 1 orbital. So I have taken all the orbitals because they are asking orbitals in this answer. Please read your questions carefully. Then complete the diagram to show the number of relative energies of the electron in an isolated atom of 14 silicon. So you are going to accommodate 14 electrons over here. So 1, 2 already given, 3 and 4, right? We show opposite spin. 5, 6, actually, how you should fill them? You should fill them like this: 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, but we just have 14, right? So they have given some extra subshells. So if you stop counting, you will get incorrect answer. So this is 2 to 4, 4 plus 6, 10, 10 plus 2, 12, and just 2 more, right? So 14. This is the configuration of silicon. The diagram shows a type of orbital. State the total number of electrons that exist in all the orbitals of this type in an atom of fluorine, not even silicon, fluorine, right? Now they are changing the question a little bit. So the first was about krypton, then silicon, and then fluorine, right? So please take care, you don't write answers, incorrect answers. So if you're reading very fast, you would just forget to read this fluorine, and what you would write? You would write the answer for silicon. So don't do that, please. State the total number of electrons that exist in all orbitals of this type in an atom of fluorine. So fluorine has 1s2, 2s2, 2p6, 1, 2, 3, 4, and these are 10 electrons. So only 5 electrons over here. So how many? All the p orbitals look the same, right? So all of these 5 electrons are in p orbital, and that is our answer. The answer is 5, right? Px looks like this, Py also looks like this, just in other plane. So not exactly like this. Let's say that Px, just a second guys, I think I should show this to you, that one looks like this and the other one looks like this, but all of them look the same, it's just the plane. So we can say all the 5 electrons exist over here like this. Then the first ionization energies of elements in the first row of D block from scandium to copper are very similar. For all of these elements, it is a 4s electron that is lost during the first ionization, because that is the outermost shell. Suggest why the first ionization energy of these elements are very similar. They are not exactly same, they are just similar. So I will write same or similar, right? Similar is a better word over here. So I will write similar electron shielding, similar atomic radius, and again the same number of electrons in outermost shell only, right? So it's either 1 or 2. So if it has similar electron shielding, it is easier to remove that electron. If it has same atomic radius, then the distance is not changing, right? And they have increasing atomic number. But first ionization energy in the first row of element of D block are very similar for all of these. It is the 4s electron that is lost. Electron lost from the same electron lost from same subshell. So all of these three things combine and makes the ionization energy similar. Hydron is a general term used to represent the ions 1H plus, 2H plus and 3H plus. All of them are hydrogen. State in terms of subatomic particles in the nucleus what is the same about these ions and what is different. So same number of protons. What are these? These are isotopes, and isotopes have been made to iron, but all of them are isotopes. So they have same number of protons and they have different number of neutrons, right? the question is about isotopes. Then what do we have next? Next is about bonding. Chlorides of some of the period 3 elements are shown in table 2.1, right? Period 3 chloride, sodium chloride, aluminum chloride, silicon chloride, phosphorus chloride, PCl5, PCl3 and SCl2. So what is the type of bonding, structure and oxidation state of the period 3 element? Right, sodium oxidation state 1, structure is, so what can be the structure? It is a giant ionic structure, right? So covalent ionic bonding and metallic bonding. We have G for giant and S for simple. Okay, bonding is ionic. AlCl3, the bonding is ionic, right? Al2Cl6, I will say covalent bonding. Structure is giant lattice, right? Ionic compound. Oxidation state is +3. SiCl4 is covalent. The structure is simple molecular. Oxidation state is +4. PCl5 is again covalent. The structure is simple molecular. Oxidation state is +5, right? Because chlorine has an oxidation state of -1 and it accommodates 5 chlorine, then the oxidation state of phosphorus should be +5. And here it is +3 and here it is +2, right? This is our table. We get 4 marks for the completion of this table. Then let's look at next question. So you have write equations for the reaction of sodium chloride and PCl5 with water. Include state symbols with both equations. Now sodium chloride is salt. So sodium chloride plus water will give you Na plus and Cl minus aqueous, right? And rather I would not write plus water, I will just write dissolved, right? But here reaction with water is asked, so this is how you write. But PCl5 is an acidic oxide. So what will it form? It will form H3PO4 and HCl, right? So how do I balance this? I need PO4 and there is only one way I can do that. So 4 to the 8, 3 over here and 5 over here. We'll also balance the 5 in PCl5. This is the balanced equation. Now, always in our paper 2 or paper 4, right? Only in IGCSE, it is okay to sometime write unbalanced equation because there is a separate mark for balancing. Over here, never ever leave any equation unbalanced. Okay, I hope you understood this. Then, in gas phase, AlCl3 exists at equilibrium with Al2Cl6 as shown. So equation 1, the forward reaction is exothermic. Complete the dot and cross diagram to show the bonding in Al2Cl6. So what has happened? This is a coordinate bonding, right? Here I will draw 1, 2, 3, 4, 5 and 6 and aluminium has shared 1 electron over here like this. Then there is another aluminium, right, which has bonded in the similar way with one more chlorine. So that is what I will first copy, correct? And we have this. Now if you notice, aluminium has 3 electrons in the outermost shell, right? So here we have shown only 1, 2, 3 and 4 electrons. Now for this to be stable, it must have 6 electrons in its outermost shell. So it's going to, aluminium is going to bond with chlorine with one more electron, right? So now this aluminium has 6 electrons in its outermost shell, right? But it will get 2 electrons as a coordinate bond. Sorry, should not draw crosses. For this we have dots, right? Chlorine, this chlorine gives 2 electrons to aluminium as a coordinate bond. So does this chlorine. And here we still have the same type of bond. And if I wanted to do this, I should erase it over here. So 1, 2, 3, 4, 5, 6, 7 and 8 electron with this chlorine, 4, 5, 6, 7 and 8 electron with this chlorine. See, I will just highlight, this is a coordinate bond, this is a coordinate bond. Here only chlorine has donated electrons to aluminium. State the effect of increase in temperature on the equilibrium mixture in equation 1. Explain your answer. As I have just said that the forward reaction is exothermic in nature. It has delta H negative. So if you increase the temperature, the reaction will happen backwards, right? The equilibrium will shift to left. More AlCl3 forms as equilibrium supports, right? We are using higher temperature. So equilibrium supports endothermic reaction and it shifts to left hand side, right? The equilibrium shifts to left hand side and AlCl3 starts forming. Let's see now what is the next question. So the question is, a 3.30 gram sample of a period 3 chloride is heated to 500 Kelvin in a sealed flask. At this temperature, chloride has a gas. Chloride is a gas of so and so volume and so pressure. Use the ideal gas equation PV equals to nRT to calculate MR of period 3 chloride. Deduce its formula. So let's do this. Now, you will need help of periodic table, right? You will also need help of data booklet where the value of R is 8.314. But from now on, you don't even have your data booklet. All the data will be given in the question because this is an older question. The data is not given over here. Anyway, let's use PV equals to nRT, right? And N is the number of moles. Once we have the number of moles, we have measured mass, we can definitely find out the relative molecular mass. So let's first input all the values, kilopascal, so 10 to the power 3 into volume. The volume is 250 centimeter cube. We have to change this to meter cube. So 100 centimeter is equal to 1 meter and cube that should be equal to number of moles which we are trying to find into 8.314, which is the value of R, and 500 Kelvin, which is the given temperature, right? Always do this. First write the formula, then the values, and then make the subject of formula your required value into 10 to the power 3 into 250 upon 100 cube divided by 8.314 multiplied by 500. Let's do this. So you have 323 into 10 to the power 3 multiplied by 250 divided by 8.314 into 500 into 100 cube. Okay. You have the value of n comes to 0.192. 1942, sorry, 1942. So I'll use 0.194, right? Now the formula for moles is measured mass upon relative molecular or formula mass. So I have MR is equal to M upon N, right? So I have measured mass is 3.30, N is 0.194. So I'll simply do 3.30 divided by answer, which gives me 169.88, right? So you have answer as 170. You can write 169.88 is 170. Now what you will do over here? So period 3 chloride, right? So I know aluminium is a period 3 metal, right? What else is? I just went to see the masses. So period 3, one mistake I made was I should be looking at sodium, magnesium, aluminium, silicon, all of them, right? And then find out the MR. So chlorine has a mass of 35.5. 35.5 into X, because I don't know what is the formula of period 3 chloride, right? It will depend on which is the element with the chloride. Okay, so it is heated to 500 Kelvin and it is a gas. Let's see, sodium chloride, right? NaCl. The mass of sodium is 23, this is 24, right? Aluminium has 13 electrons. So let's say if it was 26 and this was 28, right? 14 to the 28. We have silicon phosphorus, right? 31. Phosphorus has a mass of 31. Let's see. So we have 31 and two chlorides of phosphorus, SiCl4. We just saw in a question SiCl4 is possible. So 35.5 multiplied by 4 is 142 and 170 minus 142 is 28, which is the mass of SiCl4. So ideally you now have to check which is the proper, which gives the proper mass and which is the proper formula. Now see, because they have given gas, I would start with non-metal and the first non-metal is silicon, right? Which is why I will do this. If it was a giant molecular structure, I will not even go and find out the mass. So SiCl4 gives me the perfect answer, right? 1, 7 and 0, right? So that is your answer. Then we have, I think we missed a question. Let's see. No, we have not. Okay. OH aqueous reacts with 2-bromo 2-methyl propane in SN1 reaction, right? The molecular ion CH3 thrice C plus forms as an intermediate in this reaction. Draw the mechanism for SN1 of OH minus with 2-bromo 2-methyl propane. So first let's draw that. 2-bromo, you can take, obviously you can take hints from here, right? CH3, C, CH3, CH3 and Br, right? 2-bromo 2-methyl propane. 1, 2, 3. Meth probe 2-bromo 2-methyl propane. That is what the name is, right? Now, induced dipoles, lone pair of electrons and curly arrows as appropriate. Draw the structure of organic reactant and organic product. So this is your organic reactant. This is slightly negatively charged, right? What will happen? Okay, let's start over here that OH is minus, right? What will happen? This will take away the lone pair of electron. When this takes away the lone pair of electron, let's say this is slightly positive, this is slightly negative charge. So what you will have? You will have this and this OH minus, right? The electron goes to this. When electron goes to this, you have CH3, CH3, CH3 should draw C over here, right? And OH. Okay. So OH reacts with 2-bromo 2-methyl propane in an SN1 reaction. So I know the intermediate is not bonded to OH minus and Br together, right? That is what an SN1 reaction is. How do I know it will undergo SN1? Because we are talking about the tertiary carbocation. If it was a primary carbocation, things would be different, right? Now, 2-bromo 2-methyl propane is a tertiary bromo alkane. Define tertiary bromo alkane. Bromine. Should I write bromine? No. Let's write carbon bonded to bromine also bonded to 3 other carbon, right? Carbon bonded to bromine is bonded to 3 other carbon. It is tertiary. If it was bonded to 2 other carbon, it would be secondary. Bonded to 1 other carbon, it would be primary, right? Then organic compound M forms when 2-bromo-2-methyl propane is heated with ethanolic OH minus. What does ethanolic OH minus does? It does elimination, right? So I will draw 2-bromo, the same compound, right? No different compound. So what happens over here? If you use ethanolic OH minus, a Br and one of the H from the neighboring carbon will be removed. What will happen? You will see double bond, right? You can also draw a skeletal structure that looks something like this. This will be your answer over here, right? Elimination, ethanolic OH minus, elimination. Then HI gas can be formed by reacting H2 gas with I2 gas. The reaction is reversible and an equilibrium forms quickly at higher temperatures. Construct an expression for equilibrium constant Kp for the reaction of H2 and I2 to form HI gas. Now we'll have to consider stoichiometric ratios over here. This is 1 and this is 1. So Kp is partial pressure of HI whole square, right? And partial pressure of H2 multiplied by the partial pressure of I2, right? This will be the equation. Equilibrium partial pressure of gases at 200 is as follows. Calculate Kp for this reaction, right? We will also need to write the units. So using that equation, I have partial pressure of Hi whole square divided by partial pressure of H2 and the partial pressure of I2, right? So it is 895 square, 4800 square upon 895. Now here if you write, the unit is Pascal square upon Pascal square. So in this case the value of Kp is a unitless number. So I'll have 4800 square divided by 895 square. So you get 28.76. This is your value of Kp. Then we have state how the value of Kp would change if at all the reaction were carried out at 100 degree rather than 200. Explain your answer. For this we will need a reason, we'll need at least some knowledge that is the reaction exothermic or endothermic. Let's read the question again. Hi is formed by reacting this. This reaction is reversible and equilibrium forms quickly at high temperature. So if equilibrium forms quickly at high temperature, then it means the reaction is endothermic in nature. If the reaction is endothermic in nature, so they are asking, show how the value would change if at all the reaction were carried out at 100 degrees Celsius rather than 200. So if you decrease the temperature, as forward reaction is endothermic, the equilibrium forms slowly, right? I think they're not asking how the equilibrium forms, they're asking about the value of, just a second guys, they're asking about the values of Kp, right? What would happen as the equilibrium forms slowly, but less of the product would have now formed because the reaction is being carried out at 100 degrees Celsius. So the value of Kp, what does Kp mean? How much of the partial pressure will be of the product. So Kp value decreases, right? You would write as the reaction is endothermic, forward reaction is endothermic, the equilibrium shifts to right, shifts to right, then the value of Kp decreases. Let's see, do we have a question? No. Then we have page number 7, right? Question says compound T is an isomer of C6H12. Name T. So I will write 1, 2, 3 and 4 carbon. Meth, eth, prop, but. So I will write but. There is double bond between 2 and 3, so but 2 in. Now on the second and third carbon I have two methyl groups. So I will write 2,3-dimethyl but 2E. Draw the skeletal formula of structural isomer of T that shows cis-trans isomer. So instead of having a double bond on second carbon, if it had a double bond on first carbon, right, then it would for sure show cis-trans isomer. Okay, let's construct it like that. No, it should have on second only, but the one of the chain should be longer, right? In this case, this is a cis isomer, right? What would be the trans isomer? This will be the trans isomer. So both of them are correct answer. You can either draw cis isomer or trans isomer. But what do you have to show? You have to show that here both the CH3 are either on same side or either on different sides, and because these two bonds are different, it shows cis and trans isomerism, right? This is what happens when there is a double bond rotation loss. Then we have each carbon atom in T forms a sigma bond to at least one other carbon atom as shown. Yes, it does. On the diagram, show the orbitals that represent pi bonding that is also present in T. The pi bonding is present between the central carbons, right? So, what are those orbitals? Those orbitals look like this. But I think it is better over here if you can draw. Okay, it is better over here if you can draw the pi bond. The pi bond looks like this, right? The electrons are shared above and below the single sigma bond. State the hybridization of two carbon atoms between which pi bond forms. See, if there are just single bonds, the hybridization is sp3. If there is even one double bond, the hybridization is sp2. If there are triple bonds, the hybridization is sp. So N triple bond N also has a hybridization of sp, right? Here the hybridization is sp2 because we have double bonds. Then we have a reaction scheme starting with T is shown. Reaction 2 occurs in the presence of a catalyst. Knowledge of mechanism for this reaction is not required. Give the reagents and condition for reaction 1. Now what is happening in reaction 1? This double bond has diol, and we know only one situation where a diol arises, that is cold dilute acidified KMNO4. Otherwise, what you would have carbon dioxide or aldehyde or acid or ketone, right? Double bond can be oxidized to diol only and only if you use cold dilute acidified KMNO4, right? Okay. Sorry. We have next question. State and explain how 2,4-dinitrophenyl hydrazine DNPH can be used to detect the presence of V as a product of reaction 2. For this, we'll need to look at V. Okay, V has a carboxylic, right, bond present. So state and explain. It will give a positive test. It will give positive test. What is the positive test over here? The color changes. You can also write which color. It will give positive test as V has carbonyl bond, right? Carbon and oxygen is present. Now, the progress of reaction 2 can be monitored by infrared spectroscopy. Again, whenever there are questions like this, you will have a data besides this, right? Right now, I will answer this without data. I will not add the data values because even I don't remember those values. I just tell you what to write. You can find that out from your data booklet and write down the values. The absorption caused by OH bond is always present because water is used as a solvent. So first let's see what is reaction 2, right? I feel in reaction 2 OH was being made. So I cannot judge if OH ever forms because absorption will always be always present because water is the solvent. So what I will look for? I will look for the bond of carbon with oxygen. right? And I will look for the double bond to disappear. So I will look for double bond to disappear and I will look for this bond to form, right? Let's see. Identify two absorptions and the bonds responsible for these absorptions whose appearance will change significantly during reaction. So I will say C double bond C disappears, right? Hence, so and so absorption also disappears. What you will find in your data booklet, you will find what is the absorption number for C double bond C, and C bond O will appear, right? And hence you can write so and so absorption also appears, because now there is C bond O in the alcohol, right? Now we have one more question over here. Just a second. Yes, V is used. Okay, what is V? This is V. In a wide range of organic reactions. Some reactions of V are shown. Okay, so you're doing an iodoform test over here. Reaction 4, reduction is taking place. So this ketone reduces to alcohol. If again dehydration is taking place, then this OH and one more H, right? Water is being removed. So you have a double bond. And addition polymerization at this 2 carbon will take place to give a reactant, a product Z. V and W are V and W are colorless and soluble in water. V and W are colorless and soluble in water. State what would you observe in reaction 3? Reaction 3 is iodoform test. So you will say yellow precipitate, right? You will say yellow precipitate, that is the iodoform test. Then what do we have? Next page, next question. Reaction 3 is a redox reaction. Identify which of the reactant is reduced in this reaction. Okay, let's find out reaction 3 over here. Right? In your booklet, you will not face so many challenges because you can easily look at the left hand side page, right? Board arranges these questions in such a way that just on your left hand side you have all of this information, you're writing answer on the right hand side, which is why board leaves a lot of pages in between. They say that this page has been left deliberately to help you with this, right? In reaction 3, what has happened? In reaction 3, this is a redox reaction, okay, and what has reduced, right? Reduction is gain of electrons. So I2 has gone from having an oxidation state of 0 to an oxidation state of -1. So definitely iodine has, or I2, right? Here they have given that as I2, that has reduced. Construct an equation for reaction 4. Use hydrogen in the equation to represent the atom of hydrogen from NaBH4. So let's look at reaction 4 now. I will construct the reaction here only, it will be easier. So you have CH3 once, twice and thrice on this carbon, and that is attached to CHO, right? Rather I should write it like this, plus you should have H, right? This should give me CH3 thrice carbon, and then this carbon attached to both the OH and the H, right? Now if I have read that correctly, okay, they have written simple C6H12O. We can also do the same thing. Just 1 minute guys, why is it C6H12O? Acha, 3, 4 and 5. 3, 4, 5. Oh, sorry guys, this is CH3. So this is not like this. This is CO, CH3, and here also this is CH3. So I can write it as 3, 4, 5, 6, C6, 9, 10, 10 and 3, 13, and you have O. right? There was O in the previous reaction also. So how many hydrogens you have added? Just let's find the total again. 9, 10, 10 plus 3, 13, right? And one more hydrogen should have been added here, right? Double bond is being broken. So CH, OH and CH3. So plus 1. So 14, right? H 14. So you should write 2H over here. So what you will do? 2H plus C6H14, right? Definitely you can write this as CH3 thrice C CHOH CH3. This is also correct, right? But if they have asked it in this form, it is easier to write it in this form. X is a mixture of two optical isomers. Draw the two optical isomers in the boxes provided. Let's look at what does X look like. Okay, this is, yes, this is the chiral carbon, right? It has OH on one side, H on one side, CH3, and this on the other side. So let's draw it like that. So I have this carbon, I have, let's say, I will draw a wedge and I have OH over here. I will draw a dotted line and I have H over here. On one side I had CH3, on the other side I had CCH3 thrice, right? So here I will draw hydrogen on the wedge, right? Dotted OH. This is still CH3. This does not look like dotted. Let's, okay. And CCH3 thrice over here. Please draw it inside the box, okay? Make sure that your diagram is inside the box. But this is the answer. Both optical isomers can be dehydrated to form a single product Y. Give the reagents and conditions required for this reaction. So what do I want to eliminate? I want to eliminate OH minus and a double bond will form, right? This OH minus will take, so this OH minus can be removed and hydrogen from here can be removed to form double bond. Okay. Reagents and conditions required. So for dehydration, I think you can write, so you can write NaBH4, it is just alcohol, right? So you can simply write NaBH4. Let's see, they have they done any dehydration? Yes, they have, right? Just a second, they are asking to form a single product Y. Give the reagents and conditions. So NaBH4, I don't think it requires any conditions. So NaBH4 works, right? Then we have Y can form an addition polymer Z. Draw one repeat unit of Z. For that, let's first draw the Y. Okay, so we have 3 and then 1 and 2 and double bond over here. So we have this is there, and this is there. You have double bond over here, right? So instead of writing it in skeletal form, I think it will be easier if we can write it in this form, that this is connected to this carbon, right? So this whole thing is over here, this is this carbon, and then there is another carbon like this. So now let's erase something that is not required anymore. So we have CCH3. On this side it has hydrogen, hydrogen, hydrogen. One repeat unit. This is one repeat unit of that polymer Z, right? Then we have reaction 6 does not proceed quickly at room temperature. Suggest why this is the case. Let's see what is the reaction Z first. Reaction 6, sorry, that is the addition polymerization. The only reason it is possible is high activation energy, right? It is polymerization. You are going to break the double bond. If you are going to break the double bond and that reaction is slow, then it has high activation energy, right? This is the only explanation we can write. Then we have rate of chemical reaction is affected by changes in temperature and pressure. Draw a curve on the axis to show Boltzmann distribution of energy of particles in a sample of gases of krypton atoms at a given temperature. Label this curve T1 and label the axis. So I will draw it like this. So just a second. I will draw it like this, right? Asymptotic. Let's label this T1. On the diagrams, draw a second curve to show distribution of energies of krypton atoms at a higher temperature. But first, number of particles or number of atoms and energy, right? This is the energy distribution diagram. So they had asked us to label the axis as well, and I forgot. Now they are saying that on the diagram, draw a second curve to show distribution of energies of krypton atoms at a higher temperature and label this second curve T2. So if it is at higher temperature, right, it will have this curve a little bit at right hand side and a little bit lower because the distribution has increased. So I will write this as T2. Then what is the next question? The Boltzmann distribution assumes that particle behaves as an ideal gas. State two assumptions of kinetic theory as applied to ideal gas. Simply, the two assumptions are no intermolecular forces in gas, right? In ideal gas, the particles are not attracting each other in any way, and the volume of particles is negligible compared to the volume they occupy. So we will essentially say that the volume of particles of gases is negligible, right? That is an assumption for us to make it ideal gas. Then they are asking 2 grams of krypton Kr is placed in a sealed 5 dm cube container at 120 degree Celsius. Okay. Assume the pressure in Pascal of krypton gas in the container. Calculate the pressure. Assume it behaves as an ideal gas. If it behaves as an ideal gas, PV equals to nRT must be true. What is the pressure? That is what we have to calculate, nRT by V, right? First, let's find the N. It is 2 gram, and from the previous questions, we know that the mass should have been not 36, I think 72, right? At least double, so 2 upon 72. Let me know if I'm wrong, guys. Please check this once. You have 0.0138. This is the number of moles. So let's add all the values. So you have 0.0138 multiplied by R. It is 8.314 multiplied by temperature T. So plus 273, you must write this in Kelvin. So you have 393 as your temperature, and the volume is 5 dm cube. So 5 upon 10 dm is 1 meter. So 10 cube, right, upon 10 cube. So if I keep all of this in my calculator, 0.0138 multiplied by 8.314 multiplied by 393 divided by 5 upon 10 cube should give me 9018.02, right? So I will write 9018 or 9000 Pascal. Okay, I can write it as 90 kilopascal, which okay now makes sense. 90 kilopascal is the pressure, right? Because they have given in Pascal, you can write 9018 or you can round it off to 9000 Pascal. Then let's see what do we have next. The next question is, state and explain the conditions at which krypton behaves most like an ideal gas at low pressure, right, and high temperature, right? When it has high temperature, it has a lot of energy to move around. Low pressure means particles are far apart, right? Moves around, right? They have given state and explain. So I've stated the stated the conditions. Now I'll explain. Moves around freely at high temperature, large spaces at low pressure. So basically what we have done here, guys, is that we looked at the question that what are the conditions, what are the assumptions that we need to make for us to understand that what is an ideal gas. Now you do inverse of that. At what type of situation will it be an ideal gas? Where will it have very low intermolecular forces? So if you have very low pressure, particles are very far away from each other. And if you want them to occupy a lot of volume and still have low intermolecular forces, you increase the temperature, right? The cumulative effect will be that they behave as ideal gases. So low pressure and high temperature. Then krypton reacts with fluorine in the presence of ultraviolet light to make krypton difluoride, KrF2. Okay. Activation energy is 385 kilojoule per mole, so endothermic. Enthalpy change of formation plus 60, so again endothermic. Use this information to complete the profile diagram for the formation of KrF2. Label EA and HF in the diagram. So what you will do, reactants, this is your activation energy and this is the energy with products. I will label it, this is the activation energy, right? You can draw dotted line. So this is EA and this is delta H. Because the values are given, I will write EA is equal to plus 385 and this is plus 60.2 kilojoule per mole. I don't have the space, you can write it down. And this needs not to be at a scale, right? But should make sense. Okay, let's do this. So this should be at least, so this is 385, right? Should be at least like this, right? Much higher compared to the delta H, right? 6 times. Is not at scale, but should just give an idea that it is much greater. Explain in terms of activation energy and the collision of particles how an increase in temperature affects the rate of chemical reaction. So at higher temperature, more particles have energy greater than activation energy. Hence, more successful collisions, hence higher rate of reaction. So this is your answer, and I think with this the paper is also over. Now see guys, obviously this is a predicted paper, does not mean we have gotten the questions from the board that okay, teach this on YouTube to the kids, because the kids have not studied the whole year, they need some shortcut to score marks. No, the idea of this video is to make you understand what kind of questions to expect, right? It is also to revise you a few topics, right? I've tried to cover most of the topics in these paper. So if you forget some topics, you can come here and look at those topics and answer the questions. Anyway, thank you for watching this video. If you find this video helpful, do let me know what other subjects you want papers for, or at least do let me know, did this paper help you, or did this video help you in solving your paper. All the best for your paper. Bye bye.